Hello, I'm Kim Min-ji, and I'm going to review the paper called Unexplainable AI Model for Text-Based Patent Novelty Analysis. First, bibliography information, and the keywords of this paper are technology intelligence, patent novelty, explainable artificial intelligence, natural language processing. This is content of today's presentation. I will explain the research background of this paper. The technology and development cycle continues to accelerate, and the novelty analysis is becoming increasingly important for R&D planning as well as in the patent application process. Existing language models do not take into account the unique characters of technical elements in patent documents, nor do they provide an explanation of their decision, including which technical element represent a novelty. I will explain the research object of this paper. They developed an explainable AI model that evaluates novelty, takes into account the client structure of a patent, and provides an explanation. Also, they suggest a stable deep learning model that enables novelty analysis to handle both technical, model-oriented embeddings and client structure, not only single-sentence pair. The proposed framework of an XAI model for patent novelty consists of the following three parts. 1. Dataset construction. 2. Model architecture. And 3. Inference process. A self-explainable novelty classification model is proposed and investigated. Using the fitted model, the inference results are then analyzed by extracting patents in the field of vehicle communication networks. The inference process is done by applying the fitted model to patents in the vehicle communication network field and can be expanded to address potential applications. The proposed framework of an XAI model for patent novelty consists of the following three parts. 1. Dataset construction. 2. Model architecture. And 3. Inference process. A self-explainable novelty classification model is proposed and investigated. Using the fitted model, the inference results are then analyzed by extracting patents in the field of vehicle communication networks. The inference process is done by applying the fitted model to patents in the vehicle communication network field and can be expanded to address potential applications. This figure shows the concept of the patent novelty classification model. The proposed framework of an XAI model for patent novelty consists of the following three parts. 1. Dataset construction. 2. Model architecture. And 3. Inference process. A self-explainable novelty classification model is proposed and investigated. Using the fitted model, the inference results are then analyzed by extracting patents in the field of vehicle communication networks. The inference process is done by applying the fitted model to patents in the vehicle communication network field and can be expanded to address potential applications. First, a training dataset was designed for the patent novelty analysis. During data construction, a text-type dataset was constructed based on the target and the prior patent pairs, which is the source of the novelty analysis feature and includes bibliographic information. The new model aims to classify whether the target pattern represents true novelty or imprints on an earlier pattern. We propose a self-explainable approach where the model encodes textual information by reflecting dependencies between pattern pairs. In other words, the new model classifies pattern novelty by learning the textual element of pattern claims as a feature. In addition, the model explains the relevant claims on which the evaluation is based. Finally, we suggest the application module and apply the trained XAI model in real life. A full-text pattern dataset, which is provided by the Neural Pattern Office in EPO, was used as a training dataset. A search report reveals which prior art documents are most relevant to the field application, and it includes tagging information. Category X refers to there is prejudicial to certain claims in the prior art. They prepare for the novelty classification task based on category X of the search report. A pattern pair dataset of target data and prior pattern data was constructed for cases matching the X class. Pending pattern data include application number, a claim list related to novelty inhibition, and examination history. A prior pattern contains the application number and a related description list. It is matched with binary class 0 and 1 for pattern novelty. Class 0 is defined as a case where the target pattern imprints on a previous pattern, while Class 1 applies where the novelty of the target pattern is confirmed. After labeling the dataset was expanded based on the pattern examination history. In this study, text input data were constructed based on the dependencies between claims. The pattern examiner averaged the pattern novelty based on the claim. A claim stands for a scope of rights concerning the components of a specific technical field. Claims are divided into independent claims, dependent claims, and other technical limited specific independent claims. This study constitutes the dataset by reflecting the structural characteristics of the patent documents. First, a single set of claims in a patent was constructed based on independent claims. Then the dependent claims were expanded for each independent claims to create a set of claims. The model then trains and explains the novelty in units of claim set based on the structural relationship between independent and dependent claims. Notation used to explain the model architecture is as follows. Assume an input claim set sequence for each target patent and prior patent, where n and m denote the length of a claim set in the target and the prior patent. The suggested model for patent novelty consists of an input layer and pairwise claim set layer and interpretation layer and an output layer. The input layer generates an embedding vector for the claim set of the patent document, which corresponds to the target and the prior. In most previous NLP studies, the standard input form of word sequence has been tokenization. The pairwise claim set layer constructed a combinational pair between the claim sets included in each patent document with respect to a target and patent pair. The interpretation layer learns weight alpha by aggregating the information contained in all conditional claim sets. The output layer predicts the label's probability distribution of whether the target patent is novel or prejudicial pair art exists, is detected. These are the formulas that we used in this study. The model deals with one-to-one cases between target and power patent. The test dataset, which was delivered by using the most recent percent of the research report, is used for model inference. The inference result of the XAI model affects both the prediction class and the explanation. Model prediction evaluates novelty using two possible outcomes. One, if the target patent is novel. Two, if the target patent is novelty prejudicial, it is classified as class 0. At first, a raw dataset was obtained via a full textbook dataset of EPs from the European Patent Office. The final dataset consists of 2,500 pairwise documents with patent novelty labels. The final dataset includes 288 cases labeled 0 and 895 cases labeled 1. For language embedding, pre-trained are overt. The greater gamma is the shaper is the alpha distribution for the reflected claim set. To summarize the experimental results, the model performance improved as the effect of gamma increased. However, it was also confirmed that when gamma exceeds a specific value, the loss increases and the accuracy decreases again. Therefore, it is necessary to balance the claim set information by appropriately adjusting the value of gamma. The running-based model in this study stores our previous technical information. Therefore, it is capable of inferring the novelty of a new patent based on the random model parameter. The greater gamma is the shaper is the alpha distribution for the reflected claim set. To summarize the experimental results, the model performance improved as the effect of gamma increased. However, it was also confirmed that when gamma exceeds a specific value, the loss increases and the accuracy decreases again. Therefore, it is necessary to balance the claim set information by appropriately adjusting the value of gamma. The running-based model in this study stores our previous technical information. Therefore, it is capable of inferring the novelty of a new patent based on the random model parameter. Those cases of patent pairs where the novelty of the target patent was recognized when target patent and compared with prior art. Both patents are related to virtual assist and control devices. The relevant claim set IDs 1 and 4 denote that an explanation in the presented model includes independent claim 1 and dependent claim 4. However, the new model has still room for improvement. In particular, there are the following limitations. Technology spans vast fields, including specialized features for each technical area. In this study, the model was trained on the patent dataset accumulated across the entire technology field with any distinction between them. Therefore, if it is used in specific technical field in the future, it will be helpful to supplement it through tailored adjustments using a patent for the relevant technical field. Also, the proposed AI model unique feature is that it offers references to specific claims that are crucial for its verdict regarding novelty. However, the application of explainable deep learning model is still in its infancy. Attempts were made at providing simple, helpful explanation reference for humans. In the future, explainable AI model evolve from providing useful explanation to humans to providing feedback that accurately reflects the assessment of a highly competent human patent examiner. The main outcomes can be summarized as follows. A new deep learning model base may be very valuable in the field of technology management. Technology management traditionally needs to deal with a vastly more complex verbal structure and processing of technical elements compared to what existing natural language processing can do. Ideally, the new model would lead to practical implementation and enable the simplified interpretation of its output. The new model can be used to aid the examiner prior art research, which is very time and work intensive. Through this work, patent examiner may gain more effect access to highly relevant patents and even specific claims that may represent prior art for a new patent.